we're gonna just quickly. I'm gonna give you a few pointers before I really begin. One thing I'd like you all to do is make a new notebook, make a fresh blank new notebook. Take it, start putting your notes in it. In that notebook, what you will write is basically what you feel is important, what maybe you can refer quickly, because there's a lot of things you want to write down main things in a notebook, so anytime you want to reference it, you can quickly reference it. That's also going to help you in the interview process, during your job, and maybe in other situations as well. Okay. Of course, the notebook also comes in handy to make other notes as you keep on learning more and more once you get a job and everything. And plus, whatever stuff you read other than what I'm teaching you, you can also make notes about that. Anything you want to make a note. Having said that, always keep a notebook. And the second thing, actually, I haven't written it there. I should have. Is let me go ahead and add it in there in the PowerPoint itself. Is go to Google. Okay, Google everything, YouTube, whatever I'm teaching. Most of the stuff I'm teaching, you can find on the internet. There's no it's just not in one single place. But anything you don't understand, you can go find it. Whatever you don't understand, whatever new things you want to learn, you can go Google it on YouTube. They're going to be your best friends. While this training is going on, while you prepare for your interview, and of course when you're at work, you'll obviously you'll need to learn a lot of these things, and Google and YouTube are going to be your best friends. Okay. Now, about this class, just to make it clear, this class runs for about I would say few weeks, and depending on how much we cover in the class, we may cover a lot in maybe sometimes in 2 hours, sometimes we just cover small things in 1 hour. So it really depends. All right, but this class generally is to prepare you for being able to give an interview, possibly crack the interview, and get a job. This class is not to teach you everything you need to know as a tester. Okay, you will learn the basics, you will learn the tools, you will know how to do it. Of course, the more you practice as you go forward, you will become stronger and stronger. And because every job is different, there's no one size fits all for testing, and there's a lot of different types of testing and a lot of different types of testing jobs. There's no one size fits all. So we're gonna get you ready to get a job, crack the interview, and so on. Okay, all right. The daily homework is for you, all of you, to study on a daily basis, to read through what I've taught, try and understand what the concept is. Okay, because if you understand the concept well, you will basically be able to, you don't have to memorize things. If you understand the concept well, you will be able to speak. Okay, if you don't understand the concept, you will not be able to speak. The other reason for reading is, well, if you don't understand, then you just memorize. Okay, so that's the other reason for study. Finally, of course, because why you need to study is come time, by the time we end training, there will be a lot of stuff for you to read. So if you read every day from now on, by the time we reach the end of the class, you will be pretty much covered with most of the stuff. So you will be very close to being ready for an interview. But if you start studying at the end of the class, you will have a steep, revision curve. You may probably feel, hey, this is too much for me, and you may start feeling overwhelmed. You don't want to be in that situation. So read every day. I may conduct a random quiz. I may just on a conference call randomly start asking you guys questions. Okay, so I hope you keep up. I'm not going to get mad at anyone who doesn't answer, but that doesn't mean that I'm not going to ask. And I'm here to help you. Okay, I'm not here to spank any one of you or teach you a lesson or anything. I'm just here to train you. It's up to you to learn. Okay. Okay. Other thing is, ask me questions. Ask me questions at the end of the class. You can type it in the chat window. Also, before class, ask me questions if you have any. If you don't understand anything, ask me. Okay. A lot of times there is I've seen generally there is a hesitation in explaining, oh yeah, I understand everything, but then when I ask them a question, explain me what this means, sometimes the answer is not what I'm expecting. So ask me questions if it's a good practice. There's no dumb question, there's no wrong question, there's no stupid question. Just ask me, okay? I will provide you slides, notes, and any guides which you need to get started. And of course, I'll tell you where to get the software from. And if you cannot get it, some of the stuff I can provide you, but you will need to bring your laptop to me and leave it with me for some time, maybe sometimes a day, maybe sometimes few days, depending on which tool it is. And some of the tools don't necessarily install on all machines. So, if that is what happens, I can probably allow you to have access on one of my machines. For that, you need to, again, of course, come to me. So that's pretty much it. And we're going to go ahead and start. Before we get to the actual QA part of it, I would like you to suggest that when you have time, go to Google or YouTube or maybe both and read about some of these topics I have put in here. You want to read about, if you don't have a computer background, that is, if you don't understand what these things or what I have on the screen here mean, you have to know what an operating system is, what it does, what are different types. Just a very basic theory. I don't want you to, go into a thesis for it. Programming basics, if you know, try and read a little bit about it. If you don't have any background in programming, then it's okay. That's fine. If you can find some, read some. That's fine. That's an optional thing I want you to read. You should know what a URL is. Google it. I will tell you as we go in the class. It's basically another name for a hyperlink or website address. I am assuming all of you have basic internet skills, internet browsing, website, email, etc., etc. Search. As a tester, you should also know possibly Outlook, more than likely, because that's what is used for company email. I will just quickly show you Outlook, how it looks like one of these days, or maybe at the end of this class. You need to know a bit of Excel, okay? Microsoft Excel, the spreadsheet software, maybe Word, PowerPoint, basic tools like Notepad or whatever you have in your computer. Some basic tools like that, and basic operations like how to make a spreadsheet, saving, putting formulas, maybe adding charts. If you don't know any of that, I do have resources for Word, Excel, PowerPoint, and I might have a resource for Outlook also for you to learn. But those are very easy tools. You don't need to learn them too much in detail. You just need to perform basic operations. So you need to know that. Okay. Now the real QA stuff. Now what is software quality assurance? Well, software quality assurance is basically the process of making sure that the software, let's say for example, any piece of software, okay, let's just assume one of your phone apps, for example, like you have, let's say an iPhone or an Android, and let's say I'm sure most of you have used apps like Facebook or WhatsApp or any other, okay, or on your laptop or your computer. You may have used applications such as a Messenger or full, larger applications like maybe Word, Excel, PowerPoint, or maybe some other tools like accounting software and so on. So all of these software, what are these? These are basically applications or programs, right? So the process of or the the methods of making sure that this software meets a certain level of performance, meets a certain level of standard, maybe it provides the functionality what it's supposed to provide. So basically making sure that it meets its need. Okay, the main goal of testing or main goal of quality assurance is to make sure that it meets a certain quality. Okay, now this may mean that you are testing against making sure against a lot of different requirements that may be process related, that may be how the operations are being done in the code, or the software that may be the management side of software development. So it involves a bunch of different things. Now, a lot of companies basically spend a lot of money on building these, software. Okay, now some of these applications, like for example, Word. Microsoft has probably spent several, I don't know, thousands of hours developing different versions of Word, Excel, PowerPoint, etc. And obviously, they put in a lot of money because they need to have all the hardware, they need to have all the software, plus these skilled people who develop the software itself. So they spend billions and billions of dollars. Okay. Now, obviously, if a company is spending so much money, they don't want the effort to be paused. We don't. I mean, I'm sure a lot of you are also aware of Obamacare, which was so fast. Everybody probably knows about that. It wasn't working properly when it was launched. So when such kind of money is being spent, obviously they don't want problems with it, right? It should work as it's supposed to, as it's intended to work. Okay. So the goal of basically QA is to make sure that these software are working properly, so that all of this money, this effort is not wasted. Okay. Now, having said that, it is pretty much almost impossible to have 100% error-free software. It has always been to be something. Okay. Now, the point is what the company or the whoever is developing the software, who is in charge of it or whatever, what they can live with and what they cannot live with. Okay. All right. Why it cannot be 100% error free? Well, there are lots of reasons. For example, it may be because of the programmers are not that good, so they probably didn't do a good job at coding the software itself. Other reasons might be if they did code, but there may be limitations in the programming software itself, which is possibly causing some things to not work. There may be conflicts between two different systems because they have not properly been configured, and maybe other reasons. Okay, all right. So, uh, as far as these uh, testing is concerned, testing is basically done to just make sure the requirements are met. Okay, there's not much problems with it, and these are just the definitions for it. I will just quickly tell you that sometimes if things are not working properly, there may be serious problems. For example, I just told you there's never a chance that any software will be 100% error free. Now, the point is what we can live with, and it shouldn't be a very critical problem. Okay, let me give you an example. Okay, for example, the recent Obamacare website. Well, a website is what? A website basically is a web page, but underneath it there is an application running the whole process. Okay, the whole process of signing up for insurance through the Obamacare website or whatever website you use. There is an underlying application, okay, which communicates with other components. Okay, and we'll get into the details of what components we have. So if it's not working, then that application is not working. Then the intended outcome, let's say in this case, for example, Obamacare, you're trying to sign up for insurance, that's not going to happen, right? If it's not working. Now that is given the gravity that millions of people are going online and trying to sign up, but only 500 people were able to sign up or whatever. Now that's a huge problem for the government. So in a way, for the government, it's a critical problem. Okay. Other examples. Now this is not a life-threatening situation. There could be life-threatening situations wherein if the software or hardware is not working properly and there is some kind of an error and the system just causes a fatal error or a catastrophic error. Now, example could be you have a rocket launch. NASA is trying to launch a rocket from Fort Lauderdale, and the onboard software at the last minute has some kind of bug, okay, some kind of an error. So at the launch, what if the launch doesn't succeed? The launch doesn't even happen. That's one thing. That's non-critical. But the same thing, let's say the launch actually happened, and let's say mid-flight, something goes awry, the software has some issue, there's some error, and the rocket just explodes in midair. That's perfectly possible. It could have exploded on the ground, and those things do happen. Another example would be to like for example your hospital. You go to hospital, you have all these equipment which monitor you, like blood pressure, your heartbeat, whatever. Let's say you're in the ICU. If one of those devices which is maybe trying to, let's say a ventilator, for example, a ventilator is used to keep people alive. Now, if it's not working properly, the software controlling the ventilator is not working properly, well, the person could actually have, life-threatening problems. So the point is the software needs to be tested, okay? And most of the time, the testing is done to make sure the first most important thing in testing is to meet the requirements of the intent of the design itself of the software. Okay, when I'm saying that, now let's just say uh, I have to make a chat app like WhatsApp. Okay, so my goal would be, my requirement would be that, okay, I need an app which opens on iPhone. Okay, and then that app should allow me to access the contact list from iPhone, and then I should be able to chat directly through the internet using this app with the friends who have also installed that application, similar to what WhatsApp does, right? So that's kind of my requirement. So my design and development as a company who's developing software would revolve around these requirements. What I want, what is the intention of the software itself, and testing in turn will revolve around these requirements. So basically, the idea of testing is to make sure the requirements are met. Okay. Okay. So what it means is what is expected that needs to be done. All right. Now, I'm going to tell you very quickly and briefly about something called SDLC. This is a technical term. You want to remember what SDLC is. Okay, it's software development lifecycle. Okay. Now, when we're developing the software, let's say a company is developing the software, the development doesn't necessarily happen like everything just doesn't happen. You just say, think, oh, I need this chat app, and okay, if it's a small application, yes, that is possible. But most of the big pieces of software won't happen like that. You have to first plan what you want to do, then design it, then test it, and then make sure it's working. And that's when you will, release it. That's, it makes sense, right? Um, Same thing happens in the software development life cycle. The steps, these are the 5 basic steps. There may be different models of software development. This is the most common, simplest form of representing the software development life cycle. The first stage is basically the planning stage, wherein you basically, the company or the client, whoever is designing or wanting the software, will put up the requirements. Okay, I want this to be in the application. It should work on, let's say, Windows. That's maybe one of the requirements. It should allow me to create a file, and on so on. So getting the requirements in place. Okay, that's the first step. Because obviously, if you want to make software, you need to know what you're going to build, right? If you don't know what you're going to build, what you're going to build? You just can't just randomly start programming. So you need to know requirements. Okay. Once you know the requirements, you move on to the design phase. That's where the design of the how the application is supposed to look like is going to happen. And then the next step is implementation, which is kind of development. That's where the actual development is taking place. That's where the actual program, the coding is written. Okay. And then the verification phase. The verification phase is when you actually start making sure that whatever was in the requirements phase, whatever you thought, okay, this thing should have, the soft piece of software should have, does actually have. That's in the verification phase. Okay. So once everything is verified, everything is good to go, the final stage, once the program is ready, is the maintenance stage, wherein basically, there will be just general maintenance of the software. They will keep on checking the software and provide a general support for some time until they come up with a new version for the same software. Because obviously, like I said earlier, there may be errors which they sometimes let go. So in the initial versions, they may let go some errors. Or sometimes what happens is you didn't find any errors when you built the software. Let's just assume, even though there were errors, but let's say you didn't find them. Okay. So in the maintenance phase, let's say the client says or the company finds that, okay, here's the security problem, or here's that this application is crashing, or something, some calculation was not occurring properly. So in the maintenance phase, all those corrections will be made. Now I'm sure all of you are probably aware, your Windows very often will keeps putting that pop up in the bottom, a update is available and whatever. So that's what Microsoft is really doing. They are basically providing you maintenance. Okay, all right. So this is software development life cycle in short. Those are the 5 basic steps. You need to know those 5 basic steps. This is a very common interview question. So remember this full form, these 5 steps. Okay. Now there is also something called SDLC. It sounds very similar, but it is software testing lifecycle. Now, software testing lifecycle has pretty much a similar pattern as the SDLC. You may have different models. This is just a basic idea of what a software testing lifecycle is. This is actually, if you go back, this software testing lifecycle is part of the testing phase here. Okay, so the testing life cycle has similar planning, design, and testing phases and maintenance phases. So you have your test planning, test analysis, test design, construction and verification, testing cycles, final testing and implementation, and post implementation. Okay, so basically similarly you will have for testing, you just don't start testing just like that, right, randomly in thin air. You have to plan what the test is going to be, then you're going to analyze your plan and see, okay, this is how maybe I will do it. Then you will start designing how those tests will probably be. In the construction and verification, you will actually write test cases. We will get into what are test cases later. Okay, then you will start performing the actual testing. Okay, which will be in the testing cycles, and then you may have final testing and implementation, which may involve maybe system testing, maybe regression testing, maybe user acceptance testing. Okay, or maybe alpha testing or beta testing, and those are types of testing which we will cover as we move forward. Okay, and then post implementation is once the testing and everything is done, there may be some testing you may have to do. Okay, all right, and so one of the next items we want to know about is a bug. Now a bug basically, and that's a very common term used in the industry. You can consider it a technical term. A bug or a defect. Defect is another technical word for the bug. What it means is any kind of error, any kind of flaw, mistake, anything. There could be in the software or the application which may cause it to either perform unexpectedly or may have some things which were not expected or required in the requirements, or the intent of the application was not that. Okay, now let me give you a few examples. Let's just say you start Windows and then you wanted to make your resume, and you start trying to open Word, and then you click on File, New, Word crashed. Okay, so if Word crashed, maybe there's some problem, right? So basically it's some kind of a flaw, some kind of an error. Okay, that's one type of error that could possibly be a fatal error. Now another type of fatal error is very common in Windows environment, is when you're running your laptop or computer, suddenly everything just disappears and then you see a blue screen and there's nothing you can do, it's just power the machine off and restart. That blue screen is basically a fatal error. Okay, not so fatal errors would be something like or maybe just things which were supposed to be there in the software, and minor bugs I would call them, or non-technical bugs, but these are part of requirement. Example would be, let's say I have an application, okay, and let me just open Word here for example. Okay, let's say I have Word, okay, and let me open this. Okay, so I have this Word, I have this blank document. Okay, now let's say I have this menu file. Okay, so in the file menu, if I click on File, okay, I should have all these options, right? Now let's say instead of new, my Word for some reason says old, or maybe instead of new I mistyped it like now, or maybe instead of a white color here, which was the intention of the application, I have maybe, I don't know, pink color. Okay, so basically non-fatal errors could be of any type, okay, or non-technical errors could be of any type. I could possibly have the date in the wrong format, or let's say I have a a credit card application, credit card application, an application or a program to accept a new credit card application. Okay, so let's say I have a program to accept this, and in that, let's say my requirement is okay, first name, last name, social security number, date of birth, address, blah blah blah. Okay, so another type of bug would be missing fields. Let's say I left out the social security field, so there's no place for you to enter the social security field. So how are they going to verify it? So that is a non-technical error, but that was part of the requirement. So that is also a bug. Okay. Okay, so these are just some of the types of bugs or defects that could be there. A software may have lots of bugs, and especially in the mid, after the initial phase and in the middle to the final stages, there may be a lot of bugs. But by the end, when the application is ready, most of the bugs should have been resolved or taken care of. Okay. Problems occur mostly because of human beings, because they make an error in writing good code. Maybe sometimes human beings may also misread or misunderstand requirements. Sometimes they may forget requirements. So if I say, hey, I tell, let's say, one of you that okay, you are supposed, and you're not developer, I'm just giving an example. I say, hey, okay, Abhi, I need to write this simple calculator application, and then the requirement is it should have on-off button and numbers 1 through 0, and plus minus, it's general mathematical functions. And Abhi goes and writes the tool and app, and very nice looking, beautiful looking app, but then he forgot to put an on and off button, even though that was part of the requirement. So basically, it is very possible that you can forget something. It is very possible that you code wrong because you're not that of an expert. Okay, and the coding can be very complicated. All right. Now, usually bugs are reported. In fact, I shouldn't say usually. All the time, bugs are reported. There are something called bug reports or bug tracking reports. There are all kinds of reports you can make. Okay. All right. Now, just examples of some critical bugs. Okay, so I already told you there are different kinds of bugs possible, like wrong, something which is wrong, or something which is missing. I didn't mention extra. Now there is a possibility. Let's say this application which Abhi built. Now I gave it to one of the other guys. Let's say I gave it to Ahmed, and I told him, hey Ahmed, why don't you now add the scientific functions to it, or actually let me not go that far. Let me ask him to just add memory functions so that he whatever calculations are being done can be stored in the memory of the calculator. And he goes in and puts in that, but then he also starts adding the scientific calculating functions, which were not part of the requirement. So anything which is not part of the requirement is extra. Okay, or he may put the date, or he may put like a fancy looking clock on the calculator, which I don't really need. I don't need a clock on the calculator. I have a bunch of clocks on my desktop. I have a wall clock. I don't need a clock on the calculator. So basically, anything which is extra is also considered a bug. Okay, all right. Now, these are just another few other examples of bugs. You will not understand anything from this list. These are just names. For now, you just need to know them. When you go to the actual work environment, you may see some of these types. You may see different types of defects. Okay, all right. Now, once you start testing, okay, and by the way, when I mentioned this example of developing a calculator, you guys are not developers. You will not be developer. You will be testers. So you never do development work. That was just to give you an example. You will just be doing testing. A job of a tester is only to test. Okay, and that's going to come in handy in this slide. So we're going to talk about life cycle, bug life cycle. Now let's say I gave you this application which my team designed, and let's just say any application. Okay, let's say Word, for example. Okay, so you're testing and you find a bug. Okay, so if you find a bug, what you're gonna do? Are you just gonna try and fix it? Are you just going to go tell your manager what you're gonna do? Okay, so what happens with the bug is when you find the bug, you're gonna put it in the system. Okay? You're gonna log it in. You're gonna put it in some kind of a report. Okay, now there may be different ways. Every company uses a different method. Very commonly, you may be using some kind of test management suite or a tool. Okay, and we will cover a couple of tools when we get to it. Some companies also use Microsoft Excel or Word instead of spending money on those expensive tools. Okay, all right. Now, so obviously, once you found it, you're not gonna fix it. As a tester, you keep in mind you never fix a bug. You only report it. Okay. If ever anybody asks you what will you do or did you fix the bug or how will you fix the bug, you will always say you never fix the bug. It's the job of the developer. Okay. Okay. Now, so you've reported the bug in whatever tool or let's say Excel. Okay. So after that, what happens? What happens is that bug is assigned back to the developer. Okay. Who is it assigned to? Now, let's just say in the Word. Okay. Now there will be different sections of each application each developer may be working, or maybe you have only one developer, or you may have 10 developers. So it really depends on your particular environment. Let's just assume for a moment that you have 10 developers, because one developer situation is simple and easy. It's going to be assigned to that guy. In let's say 10 developer situation, let's say module 1 to 10. Okay, so each module is being worked on, let's say 10 developers, or possibility is in module 1 itself you have 10 sub modules, and each of those 10 sub modules, or now let's say stories. Okay, and I will get into what a story is when we get to Scrum. Okay, so each of these may be assigned certain part of development. Now, when you get that part for testing, you will probably know from meetings you will be attending at work, and from obviously the requirement documents and development and planning documents, etc., which you will have access to, uh, who is developing that particular portion where you found the bug. So when you found the bug, when you log it in, you're going to assign that bug to that particular uh, developer. Now, if you don't know, you will just report the bug. If you don't have access to that information, you will report that. If you are the test lead or the senior tester on the project, more than likely you will be assigning bug. If you're a test lead, okay, lead as in the leader, okay, you may have a manager on top of you, but you may be lead. But if you're only the tester, you may have to just report the bug, and then the test lead or the test manager will in turn assign it. Okay, but probably you may also assign it. All right. So once it's assigned, the developer will go in. He has access. The developer will have access to your reports. Okay, through either the same tool or maybe through email or whatever. So he will or she will evaluate whether that bug actually exists, whether that defect is actually there or not. Once he or she finds it, then depending on what the evaluation is, okay, what they find, they may either reject it, they may defer it, they may say they may fix it. Okay, so different possible situations. Okay, now if they decide to reject it, then obviously they will, this bug will need to be closed, and then or maybe you need to retest that that bug is there or not. Okay, rejection only happens if that bug does not exist. Okay, because you said, okay, here's a bug, but the developer checks it and he doesn't find it, then there's probably something else going on. So you both need to get together and then find out what's going on. Okay, deferred means it will be fixed later. Okay, why is it deferred? Because sometimes what may happen is there is maybe some other higher priority items which need to be taken care of first. That's one possibility. The other possibility is it's not something of a too important of a bug. Maybe I should say, in other words, low priority. Okay. Now this is another technical term. Priority. Okay. So let's say the bug is of low priority or low severity. Severity is also another technical term used when you refer to bugs, and I will cover that once we get there. So if it is not that much high priority and a high severity bug, then it may be deferred that okay, we'll fix it later. It may also, another reason is budget. Sometimes if the problem is not huge or big, the development team or the company may decide, okay, we don't think we need to fix this. It's going to exceed our budget, so they're just going to just leave it alone. Okay, so that's why sometimes it may be deferred, and sometimes when they do this because of the budget, they may actually close the bug administratively, and I will discuss what open, close, etc. is. Okay. So let's just, that's the one more condition is the developer fixes the bug. So once they fix the bug, he will retest it. He will make sure that now that bug no longer exists, and then he will send it back. Okay, that's when you as a tester will retest that same situation which was causing the bug, and if you don't find it any longer, you will just close it. Okay, if you do find it again, then you will again make your comments and reassign it back to the developer. Okay, this whole thing is actually shown in this flow chart on your right. Okay, these are two more things I would like you to read about flowcharts and read what is an algorithm. But at least read what a flowchart is, even if you don't know what an algorithm is. If you already know it, well and fine. Okay. Now, what is open, close, found, fixed in bugs? Okay. Okay. When you find a bug, okay, it is called you found. Okay, that's as simple as it is. Open, it means that that bug exists. It has not been fixed or closed. Okay. That's what the open is. So that is the state of the bug. Okay, that's a status of the bug, I should say. So, and that is actually reported. So the open status is usually so that people know. If you don't know if the bug is open or closed, how is the developer going to fix it? Okay, so the way they know is by assigning a status, and this status for an open bug is open. Okay, for a closed bug, something which has been fixed. Usually if the bug is fixed, it's called fixed. Okay, and after it is fixed, it is given a status called closed. Okay, so the closed will come at the end. Alright, that's usually because the bug has been fixed. There are some times when it may be administrative closed. If that is the case, it may still be closed, but in the notes you will probably find that why it was closed. Okay, other than that, the found and fixed is used in some companies to just keep track of how many bugs were found in a particular development cycle and how many bugs were fixed in a development cycle, so they can track progress. Okay, all right. So this is how the bug life cycle looks like, and this is also another technical thing we need to learn. All right. Now these are different types of testing. There's a bunch of these on here. These are most of these are actually based on the I would say what you need to do that test kind of thing. So most of these, except some of these testing like performance and stress, lead to a different scenario. Even though what you need to do is kind of part of it, but they actually relate to a different kind of a job also. These three: load testing, stress testing, and performance testing. I'll get into it. So these are different types of testings. Okay, and so I'll start covering each step by step. So unit testing is basically let me tell you first what a unit is. Okay, when the software is being developed, okay, let's say I have let me just go back to here and let's say open this. Okay, actually not this. Let me not show you calculate. Let me show you maybe Word. Okay. Okay, so let's say I have this Word which I need to develop. Okay, this application. So there are different these menus on top. Let me just activate my mouse. Okay, there it is. Okay, so there are these different um, tabs on top. Okay, home, insert, design, page layout, references, mailings, etc., etc. So can I build everything in one day or maybe 1 week? Maybe, if it's a small application. But if it's a big application like this one, can I build it in 1 week or maybe 1 day? No, right? And obviously each of these have some other options, lots of them. So the design process, actually not, I should say the development process, or these the whole process of development is broken down into different modules or different development periods. Okay, now within that period, you will the development team and the rest of the team will concentrate on very small portions of the development itself. They're not going to try and develop everything at the same time. They take one thing at a time and do it. Okay, so let's just say you could consider this home ribbon as maybe one module. Okay, and each of these items you could maybe consider as one unit. each of these functions which you see here could possibly be considered one unit. So basically what I'm trying to say is a unit is kind of like a building block. I'm sure all of you have probably seen Legos, right? Each piece of Legos is what? It's like a building block. Each piece is like a unit. So when you have one piece, it's a unit. But when you have bunch of pieces together, you have bunch of units. What will happen if you put them together? You can build something. That's the exact idea behind units. You make small pieces of software, and then eventually you start putting them together to build something which works together. Fine. Okay. So unit testing is basically done at the unit level. Okay. For each unit, there will be unit testing. Now, unit testing is a type of white box testing, and I will tell you what white box testing is in a bit. It is basically to test the individual unit. Okay. And white box testing, since it is a type of white box testing, unit testing is generally and mostly done by programmers. Very few jobs nowadays require the testers to know development. So you may be required to do unit testing, but as a tester generally, you will more than likely never do unit testing. So that if somebody ever asks you, you will probably say you know what unit testing is, but you can always say it is done by developers. Okay, all right. And I'm not reading through the slides. You will be getting these slides, so read through it. I'm just going to explain what it means, and I want all of you to try and read and memorize in a technical way how to define. I just told you in very simple way what a unit is and what unit testing is. Read through it, and I hope you understood it. That will help you make your own definition or answer if you need to. All right. Okay, just read through these, why you need to do unit testing and all that. Now, what is integration testing? Now, remember, I just told you, you have a bunch of units, and if you put them together, then you can build something. Okay, so for one unit, you did unit testing. So what happens if you put bunch of units together? You integrate them, right? You're bringing them together. So if you're bringing bunch of things together, now each piece individually was working. Okay, but are they working together? You need to check that. Doing that is simply what integration testing is. Okay, this also to some extent is part of developer's job, but because this now is kind of getting into the area of testing larger pieces, a tester is also involved. Okay, so integration testing is basically bringing bunch of units together and then testing if they're working. Okay, there are different types of integration testing. You can follow different methodology to perform integration testing, like a top-down approach or a bottom-up approach. A detailed explanation of that is on the third slide here. Fourth slide here. So this explains the top-down approach. Okay, and then the next one will explain the bottom-up approach and the umbrella approach. Okay, now the difference between them is very subtle. If you look at the top-down, bottom-up, and the umbrella approach, what happens in the top-down approach is the highest level modules are tested first and integrated first, and the low level is basically tested later. Okay, so it obviously has some advantages, it obviously has some disadvantages. Same thing for low bottom-up approach. Bottom-up is you start testing the lowest level first, and then you go to the higher level later. Okay, the reason is, well, it depends on the testing methodology and the type of application. Okay, to test the low level and the top level, the top down or the bottom approach, different process has to be done. So basically in the top down approach, you have basically what is called stubs. Okay, so what happens with stubs is you kind of what is the stub and the driver. Okay, now for the bottom up you will see drivers, and for the top down you will see stubs. These are more or less like kind of temporary plugins, or kind of a simulated environment for testing the higher level and the lower level logic, respectively. If you want to learn more about it in detail, I can, if you ask me, give you a link later. But even if you read through this general, you have a good idea of what integration testing is. and these approaches are. And even if you don't know these approaches, that's fine. If you just remember what integration testing means, that's fair enough. Okay. Now, what is glass box testing or white box testing? And I just told you that unit testing is kind of a white box testing. White box testing basically refers to testing wherein the tester, and in this case, of course, this is a programmer, like I said, only the programmer is doing the testing. That's because in white box testing, the programmer is obviously aware of the internal structure, and in white box testing, you need to be aware of the internal structure, the internal code of this the application. So if you don't know why 2 plus 2 is happening in an application, or 4 plus 5 or 4 multiplied by 5 is happening in an application, then you don't know the code. You don't know how actually that operation was performed. Okay, so basically, white box testing is if you know the internal structure, you know the program. Okay, all right. Now, black box testing, which is the next item, is actually the exact opposite of it. In black box testing, you are actually testing mostly only the functionality of the application itself. As in, if I tell you, okay, uh, um, test calculator, what you do, you take the calculator and you start pressing bunch of buttons, plus minus, and then numbers, and then you see if you're getting the result. So you're testing the functionality, right? So black box testing for any application, right? Let's say I tell you to test Word. You will say, okay, you can create a file, you can save a file, you can type in a bunch of characters, and maybe type a letter or whatever, save it, change bold, italics, font, etc. So black box testing is basically testing the functionality. For black box testing, you don't need to know the underlying what's going on in the software. You don't need to know the code. You don't need to know the structure of the software itself. So in black box testing, you're only testing the functionality. Okay, basically what you see or what you can work with. Like for example, in Word, you work with the front end or the graphical interface, wherein you click on File, New, and then you create a new file. In a calculator, you will obviously be pressing buttons. So those are your interfaces, right? In a white box testing, you are actually going inside. Let's say if it's a calculator application, okay, then you will see how the code is doing the calculation. And let's say in the Word, if you're testing Word, for example, you will actually go and see the programming inside it. Why something, how the new file is being created, what is the underlying function or method or the variables or the data types and so on, all the different stuff which is undergoing it, the classes, the objects, what's going on underneath. Okay, and you can read about what a class object, that's all programming side. Okay, to say it in a simple word, let's say you have a hardware calculator, not actually a program which is running on your computer, a hardware as in handheld calculator. Now let's just assume for a moment you are a white box tester. If you are a white box tester, you are basically looking on the internals, as in the chip and the wiring and whatever is inside. So that's kind of like the programming stuff, right? And if you're a black box tester, you're just testing, just pressing the buttons and seeing if the output is coming after you press the button or not. So that's it. That's the simplest way of saying the difference between white box and black box. Now there is also something called a gray box testing, which is basically a hybrid of white and black box. All right. Okay. System testing is another type of testing. This basically is done to test the entire system. And when I'm saying entire system, let's say, to give you an example, let's say your iPhone or your Samsung phone. Okay, by itself, your phone is a system. Okay. So let's just say if I own Apple and I'm on the development team of the newest iPhone, the newest iOS software or whatever, or the newest Android if you're an Android user. So system testing will be to test the entire system, right from when I switch the phone on to running applications, downloading apps, to making sure that the phone doesn't slow down, to making sure that there is enough storage space, to making sure how the RAM or the memory of the phone itself is performing. Is it full? Are applications working properly or not? Are applications crashing? Are the intended animations like the slide, scroll, finger touching, whatever, those things, everything is working. So system testing is like that. You're testing the entire system, not just one particular area. Okay. Now system testing itself is a very common word, but within the system testing, you may have these we had a bunch of list of testings before. Some of those testings will also come under system testing. So those are some of the system testings, types of testing which may come under system testing. This may not come under system testing. There may be more, but this is just an example list of some of the common types of testing which will come under system testing. Okay. All right. Now this is one of the most common testing, and this is what we are targeting. Okay. For you guys, functional testing. Functional testing is basically testing the functionality of the application or the tool or the whatever the program is. Okay, so let's just give you a really quick example. If my application is let's say calculator, so my functionality will be to get all the operations done. So as a functional tester, my job is to make sure that the calculator works. That when I press 1, it shows 1. When I press 2, it shows 2. When I press 3, it shows 3. When I say 1 plus 2 equal, it shows 1 plus 2 equal, and then it shows me the answer 3. That's what should happen. So that's what I'm doing. I'm just testing whether the functions are there or not. Another thing which I check as a functional tester is whether all the requirements are being met. The point of being a functional tester is that you're checking all the requirements are being met. For example, let's just say if I design, let's say my team is designing the new version of Windows, right? Now, obviously, let's say you sign into Windows, right? You log into Windows. Now, there has to be obviously a way to sign out and log out. So one of the requirements of the development is, or the software is, that there should be a logout button, or there should be a link to log out, or maybe there should be a button to shut down, right? Or put it in standby. So that's a requirement. So as a tester, I want to make sure I will go and check that those requirements which have been written down, which were intended to be there in the software, are there. Okay. All right. Now, GUI testing. GUI actually stands for graphical user interface. Basically, anything most of the stuff you see on computers nowadays is actually GUI based. For example, if you go to your bank, okay, your bank has a website which is you go log in and you put in your username and password, you log in. That's what you see, what you interact with. Okay, now that's basically a browser-based application. So obviously you have an interface which is called a front end, and on a Windows system, for example, instead of having a web page, you will have let's say like in Word, I had a bunch of different options to press buttons now. So what you see on the screen, where you can interact as a human being with the help of mouse or keyboard, and of course nowadays with maybe voice commands, and maybe in a year or 2 years you may actually be able to use stuff like Google Glass and stuff. So what you see on the screen, which helps you interact with the underlying application, okay, that is what is called the graphical user interface, because you can visually see it. That's why it's called graphical user interface. Okay. Now, testing of this graphical user interface is basically what your GUI testing is. Okay. So in the graphical user interface, you will look for controls like menus, buttons, icons, toolbars, menu bars, dialog boxes. If you don't understand any of this, then Google it. In fact, pretty much all the software like your Word, Excel, whatever, have it. For example, this thing here, what you see where my mouse is. This is basically a ribbon. That's a new type of tool, or object, or a control object. What you see here are tabbed. This is a tabbed menu. What you see here is the file menu. Okay, then what you see here is the status bar. So all of these different types of things, what you see on, let's say, a home button. Okay, so these are all like buttons. Okay, then this is like a drop down, and within the drop down you have a bunch of other stuff. So in a GUI, basically you're checking all these basic visual items are available or not. Okay. This is just a quick short checklist of items you will be looking for. These examples, I think, pretty much self-explanatory. If you have questions, you can just go through it and ask them. Okay, next slide. Front end and back end testing. Well, front end basically refers to what you see, right? Where you interact with the computer or the application. So, like I said, your let's say your bank website is your front end. um, your you go to email, your your login, what you see, the web page, your your email, your inbox, that is all front end. Okay, your email is obviously not stored on your computer. Okay, all of that email is actually stored somewhere else. Where is it stored? It is stored in some kind of a database somewhere. Okay, on a server. Now anything which has to do with data is like, for example, again, your email is actually not stored on your computer. It's stored somewhere in a database, somewhere on a server. So testing of that server, testing of that database is basically what is referred to as, so testing of that database is referred to as backend testing. Testing of the front end side, which is basically what you see on the browser, like your inbox, etc., login functionality, sending email functionality, etc. Those are all your front end side. Okay, so front end testing is testing of the front end side, back end testing is of the back end side. All right. Now, what is regression testing? Regression testing is basically okay. Let's just say I have a piece of software. Okay, let's just assume for a moment this world, and we designed. Let me go back to Word here. Okay, so let's just say we designed this home button. Okay, and let's just say when I click on one of these buttons, let's say I type some stuff here. And let's just say when I type this, okay, and I click on this, there's this increase the font size, the application suddenly crashes. It's not crashing right now, but let's assume for a moment it's crashing. Okay, or maybe it is causing something else to happen. Like maybe instead of increasing the size, it's decreasing the size. Okay, or it's not doing anything, or whatever. So let's just say there is a bug. So obviously you report a bug, whatever. Okay, that's fine. Now let's just assume the next button, okay, is working properly, right? The decreased one. Now they will, once the bug is assigned, they'll go and fix it, and then they will resend it to you. Now once they've fixed it and resend it to me, I want to make sure that everything else which was here, and I had already tested that before, it was working perfectly fine. Everything else which was working perfectly fine, but it is close by or related to that particular place where there was a bug. Okay, I want to make sure all of that stuff is still working. It has not lost its content or functionality or the intention. Okay, so that's what regression testing is. Okay, another thing is, let's say another possibility is, let's say I designed this module, right? Now this module is done, this module was not done, this where you have bold and sorry, this bullets and numbers and all that. So let's say this module was not done, this was added later. So after adding that module, is my application, all these other functions still working? Testing that is also regression testing, because I had already tested it. Okay, so the point what I'm trying to make is, if something has been tested before, and when you retest it after new functionality has been added or changes have been made or maybe bugs have been fixed, and it should still work. Testing that something which was tested again to make sure it is still working and it's not lost is basically what regression testing is. All right. Okay, that's session 1. Let me just quickly pause this.